Okay, welcome to The Explainer. Today, we're diving straight into a massive structural challenge that sits right at the intersection of advanced computer science and the law. We're going to explore an incredibly fascinating framework called the operational agency graph. Essentially, it's a tool that helps us trace exactly who is at fault when an algorithm goes rogue. I want you to start by picturing the ultimate modern legal mystery, when an artificial intelligence acts completely on its own and breaks the law. Who actually gets sued? Seriously, think about it. If an AI autonomously hallucinates and defames someone, or deploys a web scraper that steals copyrighted material, or even price fixes a housing market without direct human permission, who exactly do we hold accountable? Well, this dilemma throws us headfirst into what the sources call the accountability chasm. You see, our traditional legal doctrines were built for a totally linear world. They rely on human-centric ideas like mens rea, which means a guilty mind, and actus reus, a guilty act. But AI systems, they have this fluid agency. They're stochastic, meaning they rely on randomized probability, and they're incredibly dynamic and adaptive. They make choices, sure, but they don't have legal personhood. So the machine acts, but only humans can actually pay the price. When our traditional linear liability laws completely break down in the face of these autonomous systems, we are left with this massive accountability gap. So here is our roadmap for this explainer. First, we'll cover the AI accountability chasm, then the 3 OA pillars. Next, mapping the actors with nodes, tracing causality with weighted edges, followed by the CreatorBot case study, and finally, restoring human accountability. Let's get into it. Section 1, the AI accountability chasm. Let's look at exactly why this gap in our legal system exists at the deepest physical level of our technology. Get ready for a staggering statistic. 80 to 90%. That is the percentage of modern AI compute cycles that are essentially just hardware-level approximations. Deep inside the silicon of modern computer chips, specifically within the floating point unit, the machine isn't doing exact, perfectly trackable math. It's actually rapidly guessing using completely secret, proprietary seed tables. And this sheer volume of continuous, probabilistic guessing fundamentally scrambles human intent right at the physical level. The researchers actually refer to this phenomenon as the wood chipper effect. When your original highly specific data or intent is processed by these probabilistic chips, it's basically like throwing fruit into a giant blender. You absolutely cannot reverse engineer that resulting smoothie back into the exact original fruits. There's an irreversible loss of exact data provenance. Because the AI's internal operations create this fundamental unmappability, tracing traditional linear liability is, well, it's physically impossible. We absolutely need a totally new tool to bridge this gap. Section 2, the 3 OA pillars. Let's dive into our theoretical solution. So, operational agency, or OA, is designed as a permeable legal fiction. Now, this is a super important distinction. We are not anthropomorphizing the AI. We're not granting it legal personhood so it can act as a liability shield for some massive tech company. Not at all. Instead, OA is an ex post evidentiary tool. Think of it as an X-ray used to pierce the veil of machine autonomy. By examining the machine's functional traits, we can look right through that algorithmic black box to find the precise human choices that shaped its behavior. What's brilliant here is how we can take dense legal theory and map it cleanly onto 3 specific observable AI characteristics. Pillar 1, goal-directedness. This acts as a direct proxy for human intent, or mens rea. Pillar 2, predictive processing, which serves as a proxy for foreseeability. And Pillar 3, safety architecture, which acts as a proxy for a breach of the standard of care. By analyzing these 3 operational pillars, we can objectively evaluate the machine's emulated agency and literally translate it into legally actionable evidence against the human creators and deployers. Section 3, mapping the actors, nodes. With our theoretical foundation set, let's look at the operational agency graph itself. The operational agency graph, or OAG, is a visual methodology used to map out the fundamental building blocks of an incident. We start with the actors, which are represented as nodes. There are 3 distinct types of nodes in our complex causal web. First, the natural person. Think of an individual user issuing a prompt, or maybe a freelance fine-tuner. Second, the juridical person, like a massive corporate developer or deployer. And third, the AI agent itself, which is treated strictly as an autonomous non-person with an operational agency profile, not a liable entity. Section 4, tracing causality. Weighted edges. Now we shift our focus to how these nodes actually interact and influence each other. If the nodes are the actors in our legal drama, the edges are the script. Edges are the causal links representing the flow of influence, command, or action between 2 nodes. By mapping these edges, we are explicitly visualizing the invisible flow of causation, from the human architect, through the AI scripter, straight out to the physical or digital execution. So, how do we properly evaluate an edge? We look at three crucial attributes. Step 1, direction, an arrow showing exactly where the command flowed. Step 2, type, an open-ended label defining the nature of the interaction, like a control prompt or system design. And finally, step 3, weight. This is the crucial part because the weight is where we actually establish culpability. We score the legal significance of that specific edge as light, moderate, or heavy by applying those three OA pillars we discussed a minute ago. Section 5, the creator bot case study. Let's see how this builds our actual solution by applying it to a real high-stakes scenario. Let's trace culpability across multiple autonomous systems. Imagine this. A corporate developer designs a system called CreatorBot. A user then comes along and gives CreatorBot a prompt, but CreatorBot autonomously decides to spawn a completely separate subagent, let's call it ScraperBot, which then goes out and infringes on a copyright. Using the graph, we can trace the causal edge from the developer's system design and the edge from the user's prompt and see exactly how they converge on CreatorBot to trigger that final unlawful deployment. The absolute brilliance of the OAG is how it dynamically shifts blame based entirely on intent and action. Consider the edge between the user and CreatorBot. If a naive user simply asks for a basic market report, and the bot autonomously decides to steal copyrighted data to write it, the user's edge weight is extremely light. They had no unlawful goal. But if a malicious user explicitly prompts the bot to bypass security and scrape a competitor's proprietary database, well, their edge weight becomes heavy. Their direct instruction instilled a legally problematic goal. Oh, and the developer? They do not get off the hook just because an AI acted on its own. We analyze the edge connecting Developer Corp to CreatorBot. If discovery reveals the developer intentionally built a system with a brittle safety filter or ignored their own internal risk logs for commercial gain, their safety architecture pillar is fundamentally defective. This creates a heavy edge weight. The developer remains entirely liable for the foreseeable harms their design choices unleashed, perfectly piercing that shield of machine autonomy. Section 6, restoring human accountability. Here is how this framework successfully bridges the accountability chasm once and for all. As we move past linear liability into the era of networked AI swarms, the source material leaves us with this incredibly empowering message. The human pilot applies the intent. The agentic cell executes the sweat. We remain the sovereign pilots. There is no magical ghost in the machine, folks. A computer doesn't comprehend a legal contract, it just processes data. Humans must own their digital execution. By utilizing the operational agency graph, we finally have a concrete methodology to track the literal sweat of the brow and hold the human orchestrator fully accountable. By mapping the nodes, evaluating the edges, and applying the three pillars, the operational agency graph ensures that society isn't forced to just absorb the failures of an opaque, probabilistic guessing machine. Which leaves me with a final provocative question for you to chew on today. As we step into an unprecedented agentic era filled with autonomous digital proxies, are you ready to take full responsibility for the actions of your digital agents? Thanks for joining me on this explainer, and keep questioning the architecture around you.